This video is part of an online course of multivariable calculus, and I'm going to talk about Riemann sums for triple integrals. So let me start. We have defined just a single integral for a function of one variable like this. We defined the double integral dA for a function of two variables, x and y. Now we're going to talk about the triple integral, and then it's dv for a function of three variables. Okay, so how triple integral would work? This is called triple integral. The idea is this. I'm gonna calculate the triple integral of a function of x, y, and z. I'm gonna use dv. This is basically the volume element. So this is kind of the same idea for the double integral, that we have the area element in here. For the triple integral, we have volume element, which is dx, dy, and then z over the region R. But for R here, let me give you the idea for a simpler R, a rectangular box. Something like that. That when x is between a and b, y is between c and d, and for example z is between r and s. Just assume that we have a rectangular box and we want to calculate the triple integral of a function over this box. Okay, let me graph R. So this is x-axis. I have y-axis. Let me basically move this one a little bit down. And then I have z-axis, x-axis, y-axis, and then z-axis. Then I have this box in here. Okay, let me just move the box a little bit. And here, very good. So what I'm gonna do, exactly like the idea that we have for double integral, we're gonna divide the region R into sub boxes. Okay, and then we're gonna just basically divide the interval between a and b into, for example, n intervals, between the interval between c and d into, for example, m intervals, and then the interval between R and S into k intervals. And in that case, we just basically make very, very small boxes in here, something like this. Okay, we're gonna make it into smaller boxes. I ruined my shape, but that's okay. So when we do it, then each sub box has a volume. And the volume is what? Let me grab one of the small boxes. Okay, and then this is delta y, this side is delta x, and then this side is delta z. So delta volume would be delta x times delta y times delta z. That's the volume of each of these small boxes that we have in here. Then as before. We pick a sample point in each subbox. Let me call the sample point, for example, xi star, yj star, and then zk star. We need more indices in here, but I'm just gonna give you some ideas. And then we're gonna write the triple Reimann sum, which is what? I'm gonna write the sum of the area of the volume of the box times the value of the function at the sample point, yj and then zk. I chose a sample point, for example here it's the sample point that I get in each box, and then I calculate the value of the function at the sample point times the delta y, which would be the volume of the small box. I'm gonna sum over all of the numbers that I get after I do this. Then I'm gonna take the limit as the intervals are getting very, very small. So m, n, and k goes to infinity just to make extremely small intervals. And then I'm gonna say that this is the double integral of f, and then dv over the region R. That was the region R. Okay, so that's how we define the double integral of a function dv using the Reimann sum. There's a fact that says that the double integral, the triple integral of f dv over the region R is well defined if the function f is continuous. And also we have the analogous Fubini's theorem in here that says what? Fubini's theorem that says that the triple integral of f dv over a rectangle, I can do it with respect to z first, so z is from R to S, and then dy was between C and D actually, and then dx, which was from A to B, or you can do it with respect to dz dx dy, or you can do it with dx dy dz. Okay, so or we can do it in any of the 6 possible order. So in any of the 6 possible orders, we can take this triple integral over the rectangle. Okay, this is true. We can do it for in general region. This is just the idea for a rectangular box, but we're gonna do it for the general region as well. So on the next video, I'm gonna talk about how to compute triple integrals.